Any stories? I'll think of one, but not right now. Okay, so we are going to do the last 2 pages of section 7.3 today. The first 2 pages of section, today's only Tuesday, right?
Yes.
So this is wrong. This whole day is done, and these days are, this should be Monday, Tuesday, Wednesday, Thursday, and then Friday will be a chapter 7 test, okay? So that's actually what that should be, sorry about that. So today, or yesterday I should say, we learned a shortcut way to show that 2 triangles were similar. And if you guys remember what that was, it was called angle sim. And what it looked like is anytime you had 2 angles of one triangle congruent to 2 angles of another triangle, that was enough to say the triangles were similar. And for now, that's the only one that we know, okay? So if you guys look at this, they tell us that these 2 RS and UT are parallel. What kind of angles should we look for? Alternate interior. Do you guys get that R and T are alternate interior and S and U are alternate interior? And don't we really know that these 2 are congruent too because they're vertical, right? So in this one, it just asks us to find RQ and QT. So we don't have to do that similarity statement. We are gonna have to find X, and then we're gonna have to find RQ and QT, okay? So let's go ahead and try that. So we need to do a proportion, first of all, to find what X is. Notice that 10 is between an angle with 1 arc and 2, and so is 4. It's between an angle with 1 arc and 2. Then, I was telling you guys yesterday, like if I was just starting this, I would always think these 2 sides correspond and these 2 sides correspond, but when these 2 lines are parallel, it's actually the opposite ones that correspond. So this one and this one correspond. They're both between an angle with 1 arc and 3 arcs, 1 arc and 3 arcs, okay? When I look at this, I can write many different proportions. If I went purple of this over purple of that, 10 over 4, how would I have to write the green ones?
X over 3. Sorry, X plus, I'm trying to think of this because I did it. 2X plus 10 over X plus 3.
Yes. I went this purple over this purple, so I have to do this green over that green. So 2X plus 10 over X plus 3, okay? And now I'm gonna do cross products. So I'm gonna multiply this, and I get 10 times X plus 3 equals 4 times 2X plus 10, okay? Now I'm going to distribute. 10 times X is 10X. 10 times 3 is 30. 4 times 2X is 8X. And 4 times 10 is 40. And then I'm going to go ahead and solve that. So I'm going to bring my 8X over here. And 10X minus 8X is 2X. And then I have plus 30 equals 40. Then I would subtract my 30. And I get that 2X equals 10. divide by 2, and x is 5, okay? Now, that wasn't one thing we had to find that it asked for, but you have to find it to find what we want. And what we want is we want RQ as well as QT. So if I take that 5, I'm gonna take that 5 and put it in to RQ here, which is x plus 3. So if I take that 5, RQ would be 5 plus 3, which would be 8. Now you guys do have to show the work on this. You don't have to when you find RQ. Now the second thing it asks us for is QT, okay? And QT is right here. It's 2x plus 10. So what I would do then is I would take this 5 and put it in here. So it would be 2 times 5 plus 10, which would be 10 plus 10, which would be 20. Okay. Then there is a type of question that you're going to have here where they use like a common way to use angle similarity is if you ever need to find the height of something that is like a really tall tree or a flagpole or something like that. And to do that, what you do is you would think about, say this was a super tall tree in your yard that you did not know the height of, okay? And then you had yourself and you knew your exact height. And just to make it simple, let's say that that person is 6 feet tall, okay? What would happen is that person would go, and it'd have to be a sunny day, okay? That person would go and line up in the shadow of the tree. And they would back up, and back up until they're no longer, they're not walking, or they'd actually kind of go forward until their shadow was a part of the tree shadow. So kind of what would happen then is their triangle would fit inside the big one. So this person's 6 feet tall, and then that person could have measured before how much their shadow was, okay? So their shadow, let's just say to make it easy, is 9 feet tall, okay? So this would be 9. And then what you can do is you can do similar triangles to find what the height of the tree is, because you would know, I'm gonna take these back out. Okay, so you would know your height and your shadow's length. You don't know this, but you can measure your shadows, or the shadow of the tree, and let's say that's 21, okay? And what basically happens there is this angle and this angle ends up being the same. Like I said, you could go and stand right in there, and that's the same. So this angle, this ends up being angle, but to make it simpler, you can draw it as 2 separate triangles, and then you just do a proportion and you can find the height of any missing thing, okay? So if I look here, let's change our amounts because we're gonna do an actual question. So it says, Adam is standing next to the Palmetto building in Columbia, South Carolina. He is 6 feet tall, okay? So Adam is 6 feet tall, and the length of his shadow is 9. Oh, I ended up using the right ones. If the length of the shadow of the Palmetto building is 322.5, how tall is the building that's right there? Okay, so what we're gonna do is just set up a proportion. The way you do that proportion doesn't really matter, but the two heights would correspond as well as the two lengths of the shadows would correspond. So if I set this up, and let's say that I went green over green and I went X over 6 equals yellow over yellow, that's 322.5 over 9. Now we could go ahead and do cross products. You don't even really have to type or write anything down. What do you guys get when you go 322.5 times 6 divided by 9?
215.
215?
Yeah, 215.
And that is feet. Everybody understand that? Is that what you guys got too?
So I had the proportion of 6 over 9 and then had 322.5 equal to 9 on the bottom. I got the same answer.
You went 6 over 9 equals X over 322.5.
Correct.
Yep.
Okay.
This ratio can be written so many different ways. So you went green over yellow equals green over yellow. Yeah.
Because the way I was thinking of your height, or Adam's height in relation to his shadow is equal to the building's height in relation to its shadow.
Yep.
Okay.
Yep, absolutely. Okay, is that it on this page? Yeah? All right, so now let's go to this page. Okay, so here we have two buildings that cast shadows. So again, I'm gonna just draw two separate buildings. Just know that the reason these are similar is because of angle, okay? Now it tells us that two buildings cast shadows. One is 240 feet and one is 180 feet. The taller building is 160 feet tall. Do you guys get that the taller building should have the longest shadow? So our taller building would be here. And we want the height of the shortest building, okay? So again, how you write your proportion doesn't really matter. There's many different ways you can do it, okay? So if I was going to do this, let's say I went this over this. I went green over purple in this one. I could go green over purple in this one. So I could go 180 over 240 equals X over 180. Okay? You know what? This is supposed to be 160, isn't it?
Yes.
Sorry about that. So that makes this 160. Okay? Now, you would multiply these two and divide by 240. What do you guys get when you do 160 times 180 divided by 240? What'd you get, 120?
Yeah.
120 feet. Okay? All right. Now it says Josh wanted to measure the height of Willis Tower in Chicago. He used a 12-foot pole. So here's our 12-foot pole, and its shadow was 2 feet. So if you wanted to, you could take these out. You don't have to, but this is 12, this is 2, and then Willis Tower is X and 242. Okay? So when you do this, you would set up a proportion again. And again, the heights correspond as well as the shadow lengths correspond. So if you go to set this up, many different ways you could do it. Let's do blue over blue, 2 over 242 equals green over green, 12 over x. And then we would cross multiply. We'd multiply this and divide by 2. Did anyone get an answer? I'm guessing it's going to be between 1,300 and 1,500, something like that.
1452.
All right, 1452 feet. All right. Okay, so today, oh, we have one more, you guys. We have one more. So, it says a mailbox casts a shadow that's 4 feet 3 inches tall. Ben, make sure you pay attention, okay? A nearby tree that measures 12 feet casts an 18-foot shadow. So we have this little mailbox, okay? The shadow is, I changed this question to 4 feet 3 inches. What decimal of a foot is 3 inches? Think about that. 3 over what? It'd be
0.25.
Yeah, 3 over 12 would be 1/4, which would be 0.25. Do you guys get that? If they said 6 inches, it'd be 0.5, correct? Everybody get that? All right, so this is gonna be 4.25 feet. Here's my mailbox. And then we have this nearby tree that measures 12 feet that has an 18-foot shadow. What we want to do, I'm not really doing that great today. I put this in the wrong spot. So the 4 foot 3 inches is actually the shadow, not the height of the mailbox. So the 4.25 goes here. This is X, okay? Again, when you go to set this up, I would say these two correspond, these two correspond, and then we could write our ratio, okay? So I'm gonna go X over 12 equals 4.25 over 18. So you're gonna multiply these two and divide by 18.
2.8333.
I'm just making sure that's right. 2 times that. Did anyone else get that?
Yep.
Okay, and that is in feet. All right, so that is the first part of what we're doing today, okay? So here's the first part of your assignment. I don't know why I just didn't put a comma here. And it's saying to look at number 8 so we can talk about the lengths. So let's do that.
We have another lesson too.
Okay, so 516, page or number 8 we're gonna look at. Number 8, you're gonna have, number 8, you're going to have a cell phone tower that has a 100-foot shadow. And then at the same time, you have a 4 foot 6 inch post near the tower. So think about this, 4 feet 6 inches would be 4 point what? 5, right? 6 inches is half a foot, so this is 4.5. And then the shadow is 3 feet 4 inches. So think about that. 4 inches is what fraction of a foot? 4/12, right? Which reduces to 1/3. And what is 1/3 as a decimal? 0.33. So 4 inches over, there's 12 inches in a foot, is 1/3, and 1/3 is 0.33. So that's what it's gonna look like, and you're looking for that for number 8, okay? All right, so we're gonna do 2 pages of the next thing. And so far, what we know is we know that we had angle similarity. Today and tomorrow, we're gonna learn the last 2 ways. Shut your MacBooks, because I want you paying attention, not working on your assignment. So today and tomorrow, there's 2 additional ways that we can do. The first one is called side, side, side. And what it is they're gonna give you the 3 sides of 2 different triangles. And I'll just make one up. Let's say this is 2, 3, 4, and this one is 8, 12, 16, okay? This one you can tell is gonna be similar right by looking at it. Can you guys tell why?
Because they're all proportional to each other.
Because they're all really what? What did I do with each of these? I multiplied them by 4. And when that's the case and you look at that, you could just automatically say, yes, they're similar by, and we write this one as side, 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 sim. Now, yep,
If you had sides that were 4, 16, and 9, would they be similar as well?
to this,
Yeah. Would it work if you're squaring?
no,
Okay.
no. It has to be, when you divide them, they would be the same ratio.
Oh, yeah, that makes sense.
Yeah, so like 2/4, 4/16, 2/4 is a half, 4/16 is a quarter,
Right.
3/9 is a third.
Okay.
Okay, good question though. Then the second way, oh, and by the way, you guys, how we do this, because normally you can't just tell that I multiplied by something or divided by something. This is where we go small over small, okay? Medium over medium, just like we did earlier in this chapter. And then we do large over large, and we see if all 3 of these ratios are the same, then we can say that they are similar by side, 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 sim. The second way that we can do this is called side angle side similarity. Just like with congruent triangles, side angle side, the angle has to be right in between the 2 sides, okay? The angle has to be right in between the 2 sides. Your angles have to be congruent. The sides have to be, this one's too easy. Let's do, can you tell on this one that it's proportional? Yeah. Didn't I just divide by 5 on both of those? So you can tell that too. But in this one, normally you couldn't, so you'd go small over small. And here we only have 2 sides, and then we'd go large over large. Okay? So if we go down here, this is what this question is asking. So first we have to check, are they similar? If yes, they want us to write the similarity statement. And then when they say explain your reasoning, it means, is it side, side, side sim or side angle side sim? Now in this one, we're given all 3 sides. So what I'm gonna do is small over small, medium over medium, and large over large. If all three of those end up being the same, they are similar. If two of them are not the same, I can stop and just say no. So smallest side of this triangle is 6. Smallest side of this triangle is 9. What does 6 over 9 reduce to? 2/3. Very good. Then I need to do medium over medium. Medium is 8. Medium size side here is 12. Doesn't 4 go into each of those? 4 goes in here twice. 4 goes in here 3 times. Okay, so far we're good. Then if I do large, which is 10, over largest here, which is 15, 5 goes into each of those, so this is 2 over 3. Now, all of them are the same, so that means they're similar, and we have to write a similarity statement. In these, you have just the sides that you have to write a similarity statement with, and order does matter. So this is what I do when I'm doing this. I go along the side that is smallest and then the side that's biggest. So I would call this triangle ACB. ACB. So I went along the smallest and then the medium sized side. I would do the same order in this one. I'd go along the smallest and then the medium sized side. So I'd call this DFE. So I'd go similar to triangle DFE. And then you would just say, how did you know that? This one is by side, side, side. And then you do have to do the similarity statement by it, or the similarity symbol by it. Okay, now let's look at this one. Do you guys agree in this one we're looking for side angle side? And our angles are good. So in this one, we have to do small over small. And then you could just think of it as large over large. Okay, smallest side here is 10. Smallest side here is 15. 5 goes into each of those, so this would be 2, this would be 3. For large over large, this is 14, this is 21. Is that 2/3 also? 7 goes into each of those, 7 goes in here twice, 7 goes in here 3 times. So these end up being similar also. So what we're gonna do there is we're gonna say triangle, and again, when I write this, I'm gonna go along the smaller side and then the medium size. So I'm gonna call this TSU is similar to, and again, I'm gonna go along the smaller and then the bigger, so I'm gonna go PJM. And then we used, for this one, we used side angle side sim. Do you guys all remember how to reduce a fraction on your graphing calculator? You'd go 14 divided by 21, math, enter, enter, and it'll reduce it if that's something that you don't know how to do. Now, if I look at this one, which one do you think we'd think about?
Probably side angle side.
Yep, because we have 2 sides and an angle. Is this angle where it should be?
No.
No. So when it's not, this should be right here, right? When it's not in the right spot, all you have to say is no, and you don't have to do anything else. That angle would have to be in the correct spot in both triangles. You don't have to say why or anything. Now let's go to this page, okay? Tell me something we know that I could mark on this. Yep.
Angle SRW is congruent to angle TRB.
Yep. These are what kind of angles?
Vertical angles.
Vertical angles. So we have 2 sides and an angle. Side angle side. Is the angle where it should be? Is the angle in between the 2 sides? No. So this one, we just write no. Do you guys agree that the angles should be right here and right there? Everybody understand that? Okay. Now let's look at this one. If you guys have a graphing calculator, decimals shouldn't be a bother because you can just type it into your graphing calculator and it will reduce it. If you don't have a graphing calculator and everything has one decimal point, you can multiply every number by 10, which would get rid of all of these decimals. So this would just become 66, this would be 82, this would be 124, 111, 55, and 71. And that might be a little bit easier to work with, okay? So this one we're looking for side, side, side. So the first thing I'm gonna do is check smallest side over smallest side. The smallest side here, I'm gonna use the 66. Smallest side here is 55. Now this one I can reduce in my head because 11 goes into both of those. 66 divided by 11 is 6. 55 divided by 11 is 5. So that is what that simplifies down to. Then what I'm gonna do is do medium over medium. When I do that, the medium size side here is 82. The medium size side here is 71, okay? If I go to my calculator and I try to reduce 82 divided by 71, math, enter, enter, it doesn't reduce. So what that means is this one is reduced already, and this and that one do not agree. So then we just say no, and we can move on to the next one, okay? If I look at this one, what do you think they want us to think?
Side angle side.
Side angle side. Is this angle in the right spot?
Yes.
Is this angle in the right spot?
No.
Shouldn't it be right there?
Correct.
Correct? So then we just say no. So you're gonna like the ones that are no's. Now this one here is a little bit harder. Do you guys get that this little triangle and the big triangle share that angle? Okay, and this one I would suggest taking these two apart. So this is 10, this is 12, this is M, N, P, and that has angle M. Then over here, I have M, I'm gonna do the whole triangle, R, S. What do you guys think this side is gonna be?
25.
Yep. And how about this side? 30. Okay. And so we have our two angles because they both have angle M. Now I just have to do small over small. And in this case, I could think of it as large over large because I only have two. Smallest side here is 10. Smallest side here is 25. 5 goes into both of those and it reduces to 2/5. Largest side is 12. Largest side is 30. 6 goes into both of those. 6 goes in here twice. 6 goes in here 5 times. So they're similar, okay? And then what we have left, we have to say what the triangle similarity is. When you have two sides, again, I go along the side with the smallest side and then the medium. So I'd say triangle NMP is similar to triangle. And again, I'm gonna go along the side with the smallest side and then the medium, or in this case, bigger. So this is RMS. And then you just have to say which one we use, and it's side angle side sim. All right, one more. we look at this one, we know that we have a right angle here, which would make it have a right angle there. If you look at this side triangle here, what I know is I have a side that's 12, a side that's 8, and a right angle. So what would make me think is side angle side. Is that angle in the right spot?
No.
No. And on this side too, I have a right angle and I have two sides, but that angle would need to be there. And so this one would just be no. Okay. Now this is your assignment for this one. So it says, for these, just say yes or no, write the similarity statement, and state if it's angle sim, side sim, or side angle side sim. Okay? Did you think it was hard today or just long?
Just long.
Long, I'm sorry. Tomorrow will be shorter. I promise.
Probably some longer lessons.
Yeah.
Get me over there. I can get in here too. Oh, thank you, quicker. Here. Yeah, get going. No. Yes. Are you doing coffee or doing right?
My bad, I must have